Hey everybody, I'm Amanda with DevExpress and welcome to today's webinar, ASP.NET Security Best Practices, presented by DevExpress CTO Julian Bucknell and DevExpress Technical Evangelist Paul Usher. In this session, they will explore how to ensure your website is secure with some best practices surrounding DevExpress ASP.NET controls. In this webinar, you'll learn how to protect your site and users when uploading files, stop XSS, cross-site scripting being used to hijack information, ensure reports and dashboards are visible to the correct user and groups, and prevent cross-site request forgeries. This presentation will cover examples for both ASP.NET MVC and WebForms and includes example code to allow you to test your existing sites. This session is being recorded and it will be made available on our DevExpress YouTube channel later today, and we will send the link to the recording in a follow-up email. We will also do a live Q&A at the end of this presentation. Just type your questions in the GoToWebinar control panel at any time throughout the broadcast. All right, thank you so much for joining us. I will now hand things over to Paul and Julian.
Thank you, Amanda. Good morning, everyone, and welcome to today's presentation. Good morning, Julian.
Good morning, Paul, and good morning, everybody attending, basically. And welcome to ASP.NET Security Best Practices. And I would just like to point out at this particular junction that I am the real Julian Bucknell. I am not an intruder or malefactor. So there.
I think you are.
So what we're going to talk about today are some of the security best practices that you should be using right now in your web applications, be they WebForms or MVC.
Correct. In particular, we're going to look at the use of external files for malicious code attacks. We're going to look at differences or different types of denial of service attacks, cross-site scripting, and cross-site request forgeries. The examples I'm working from today are available on our GitHub page. I'll be posting a link to that later on, or showing you the link. And we do have a mix of some WebForms and some MVC to show you, just to break it up a little. I don't want to get too bogged down necessarily in all the code. We're wanting to show you best practices, what to look for, where to get the answers. And of course, we're directly relating this to our ASP.NET UI controls. Julian, I'll be asking you to explain a little bit of each of these attacks as we move through, if that's okay.
Okay, no problem. So the very first one here, we have malicious code attacks. Now, this is essentially more about allowing your end users to upload files to your web application. Now, you might think to yourself, you know, web application, it's on a web server. Here I am in my browser. There's this kind of nebulous bit in the middle, but really it's just me talking to the web server, and vice versa, the web server talking to me. The problem is, if I'm not me, but I'm going to be using the word bad actor throughout here, because malefactor I can't say very well and so on. So a bad actor has the same kind of access to your web application as one of your real users. And here we're going to be talking with malicious code attacks about uploading files. You may have a web application that allows your end users to upload files. It may be just, say, images, there may be documents, they may be anything that's important to your particular business. Now, the problem is your bad actor can upload files which will do nasty things. So the first thing we're going to talk about is preventing uploading of some malicious files. How do we stop the hackers out there uploading stuff that you don't really want in your web application?
In particular, we don't want things to be exposed, so we don't want access to web config information or other things. And this first example is going to focus on how to stop somebody uploading an executable page into your application. Now, this example works with IIS or anything based on IIS, so some of the cloud servers. And we'll start by looking at what happens when I upload a page or a file. Here we've got a standard DevExpress file control straight out of the box. And what I'm going to do is choose this malicious ASPX file to upload and say upload. At that point, it's done. It's in there, and all it requires is somebody to do a little bit of sniffing or to even guess what folder that you've actually saved that to. And it wouldn't be an uncommon thing to have an uploads folder or an images folder, as we've got in this example. But having just uploaded that page, I can now go to that location and execute it. And you can see here that my page, and I'll show you the code for this particular page, you can see that it's actually gone and retrieved the entries of my configuration, my config files for database access. So within seconds, I've now got a listing of what the connection strings are for that particular web page. And to show you just how easy it is to do that, I'm going to jump over to VS Code and remember to use the correct shortcut key instead of my Mac key, and go into uploaded files, images, and we'll see this is where the file was actually uploaded into. It in of itself is a very simple ASPX file, not doing anything special. On page load, it's running through all the entries of the connection strings from web.config. So we can see how easy it is to expose that. And of course, just from that, you can imagine how easy it is to get access to other things, information on the server, local files on the server, because you're executing a page as if it's part of your website. And then here we're just showing you how we spat out the information on that. Now, to show you that that's actually a live example, make sure I'm in the right project, and I'm going to come to my web config, and where we had no username and password, I'm going to put Julian and a password of, that's your usual one, isn't it, Julian? Damn.
Oh, now I've got to change it.
No, I may need to reset that. Nope, there we go. And you can see that that's actually reading that in real time from that uploaded file. The thing that should get people's attention is how easy that was to do without too much effort from a hacker, even a script kiddie type scenario. So now what we want to do is actually look at what's required, or how do we mitigate those particular set of circumstances. First thing we're going to do is talk about what the settings could be on the upload control itself. So I'm going to jump to my upload markup page. And if I know that I'm expecting a particular file type, the simplest thing is obviously just to set that allowed file extension. So now I only want JPEGs or PNG files to be allowed. What effect is that going to have on how things are processed? Let's run the example again. Browse. And now we can see that I'm not seeing my malicious file. And if I do actually try and select it, I'm going to get a message saying that file extension isn't allowed. So that's a very simple step to take depending on what you want to upload.
And that's important, actually, because we basically write the upload file control to accept any file whatsoever. We didn't want to limit it in code, shall we say, to say just images or just documents or anything like that. After all, it's your web application. If you're uploading files for a reason. They're particular files which are required by your web application or by your business or whatever it happens to be. So it's up to you to limit the file extensions that will be allowed for your particular application.
Absolutely. Now, the other thing you can do is you can also set the validation settings inside your an event, either the init event or depending on how you've got the file upload control set, but you can set the allowed extensions in code behind as well. There's a couple of other things that you can consider. One, if I switch back to VS Code, is the addition of something like this into your web config, which will actually stop the items inside that folder from being executed. So it would be a read property. And of course, as Julian is just touching on, the things like the upload control supports file types out of the box of any type. The binary image, the same, file manager. We've got some default or some preset allowed extensions on the HTML editor, such of the image types, MP3, MP4, OGG, and Flash file. Rich text edit supports or allows extensions of the doc, docx, EPUB, etc. Spreadsheet control, XLS, XLSM, and all the usual extensions, including .txt, .csv. So there is another thing that we can do, particularly where images are concerned, but I'll be looking at that when we get to the binary image section. So next, what I'd like to look at is how to prevent uncontrolled resource consumption. Now, what do I actually mean by that? Another phrase might be a DOS or denial of service attack. Julian?
So basically, your web application is accepting users to upload files. And the issue becomes, if you like, the denial of service attack is, I'm not going to be talking about the DDoS, distributed denial of service attack. Denial of service attack is, for example, hey, I'm going to upload a huge file to this server and just let's watch the web application die on its feet. It also involves how you're going to be processing these files on the server. Are you just going to be putting them into a folder, or are you going to actually be, say it's a CSV file and you want to extract the information out of the CSV file and put it in the database? You know, all of those kind of things could be susceptible to some kind of denial of service through a bad actor, say, uploading a lot of files very quickly, or big files, or whatever it happens to be. We're going to try and, through our code, control the consumption of resources on the server, so memory, disk space, processor time, and so on and so forth, to allow you know, good response times from your normal end users, not your bad actors.
So typically, as Julie mentioned there, what we're wanting to do is stop anything that's going to be taking up too much memory, too much CPU space, time, or too much hard drive space when uploading files. In particular, we're talking, or usually large files that will do that. Now, there's nothing special in the actual markup here. I've got a packet size set here, but what we do want to do is actually look at the code inside. Now, our do processing thread at the moment is simply, or do processing event is simply running up a long thread to emulate some delayed processing time. The two things that I want to focus on. When you're looking at files, a bad approach is actually processing file bytes. So we're going to comment that one out.
The reason for that is file bytes basically reads the entire file into memory. You don't want to do that. You want to process a file in chunks. And that's why a good approach here is to use streams. With a stream, you're going to be, or rather the runtime will be reading the file in chunks and will be processing them in chunks, and then you read the next chunk and then you process the next chunk. So it doesn't mitigate the problem about processing a huge file per se. You're still going to be spending a lot of time reading the chunks and all the rest of it, but at least you are not going to be constraining your memory. After all, a web server is processing several requests at the same time. It's not just doing one request at a time. It's doing lots.
Sometimes,
if you have a popular web application.
Yeah, sometimes tens of thousands.
Mm-hmm.
So a couple of other things. People might already know that setting up your web config, you've got inside your HTTP runtime, you can set the max request length, and in request limits, you can set the max allowed content length. The problem with that approach, especially if you're using a control such as ours, is we upload smaller fragments by default. So only a couple hundred K at a time, so that that connection gets to stay open. So that's going to bypass some of those behind the scene approaches for uploading large files. So this approach, you can set a maximum file size within the upload control, which will also help. Now, the HTML editor control and the spreadsheet control do have a ceiling for uploaded file sizes. Any guesses as to what that is?
It's actually 30 megabytes or more. That's again the issue. We are writing a general control. It's up to you to define the limits of that control. So for a file upload control, for example, define the maximum file size you're going to accept. I mean, 30 megabytes is probably a little large, but you know.
Well, for most people, I know that the internet's getting faster and faster around the world, but there are still people that struggle with slower speeds, and 30 megabytes could still take considerable time to actually upload. So having a few pages open doing that.
Yeah, be aware of that particular property. Set your maximum file size, whatever upload control you're using. Do remember to set it. You know, if you're an HTML editor, how many HTML files do you know that are 30 megabytes in size?
I've seen your blog posts.
Oh, thank you.
So
consider limiting it in that sense as well.
Now, the file manager control by default allows files to be uploaded and does not impose any file size or extension. But you can disable the file uploading simply enough by setting the settings upload enabled false in the markup. And of course, you can also alter other operations by file manager, such as copy, delete, download, which are all configured using the settings editing property. And most of those are disabled by default. So the next thing on my hit list, Julian, is the use of temporary files. Now, the process or the approach here would be that you've got an end user is allowed to upload, I don't know, a spreadsheet that you're going to process into a database later, or a text file that you're going to process into a database later. This ability for uploading information for later consumption by another process, and it's sitting in a temporary area. There's a danger here that will allow third parties to get to that information, which of course is a big no-no. When we look at
the first thing to do,
sorry, you go.
The first thing, of course, is if you're just allowing your end user to upload files for later processing, is don't put them in a folder that's accessible through a URL. Paul showed an example earlier on where he was uploading a file into the images folder, and it's kind of obvious, hey, we're uploading an image, it's probably going to be in a folder called images, and oh, lo and behold, there it is. Be aware of the fact you can hide folders from being accessible through a URL. The biggest example here is app data, which Paul is currently pointing at. App data is not accessible through a URL. So be aware that you can do that, and do it. If you're having temporary files and you're processing them later, put them in a temporary file folder that's not accessible through a URL.
And then additional options here would be to use a dedicated extension for your temporary file. So instead of just taking the user's file name with their extension, you could create your own custom that's going to make it extremely difficult for people to consider.
Again, this is all about making things more secure. You may think to yourself, well, you know, my temporary folder is not accessible through a URL. Why do I need to do all this? Just, you know, layer on some security here. And I really like this bit previous to the my temp extension here, the get random file name for your temporary files. It's a new one on me. I didn't actually know this existed in wherever it exists.
It's been in the framework.
System.io.
Yeah, it's been in the framework for as long as the framework's existed, Julian, and it's part of io.path. And there's a couple of calls which people might not be aware of and are certainly useful. There's get random file name and get temp file name. Now there's a subtle difference between the two. The get random file name will return a cryptographically strong random string that can be used as either a folder name or a file name. But unlike get temp file, it doesn't create anything on the disk. So if you use get temp file, it creates a 0-byte file already for you.
So yeah, the random file name, the assumption is it's going to be cryptographically secure. Therefore, it's not going to, it's like a GUID. You're not going to get the same GUID twice in a row. So automatically you have a unique name, whereas the get temporary file name, or get temp file name, I should say, has to create a file there just to make sure that that particular temp file name is never used again.
One thing to note here, though, is get random file name, if you do want to use it, does automatically include an extension, so you need to strip that off, or be careful that you're using your extension on top of that.
Great. So with temporary files, make sure your folder is inaccessible to the outside world, I should say. Obviously, it's going to be accessible to your web server. That's the important thing about, if you can execute code on the web server, you've got access to the entire file structure, entire folder structure. And if you're using temporary files, then by all means, create random file names and process them later, or temporary file names, and don't accept what the user gives you as a file name.
Absolutely. And I'm just going to jump over the browser for a second. If you're using the DevExpress SPX file manager control, then you can use the access permissions for setting rules against each of those folders. So there's a great document here inside the support center, or the documentation, showing what and how to set those rules up for different things. So there's some great examples as well if you're wanting to specifically allow certain things to be shown, uploaded, etc., etc. Next on our hit list, we've covered 3 big ones so far: malicious files, the DOS, and now we're going to take a look at binary images.
And this is kind of an important aspect of web applications. I'm just trying. You generally let people upload images so that they can view them later. An example is your avatar for somebody. Maybe your web application allows your end users to have an avatar that they can see when they're ordering a product, or writing something on some thread in a conversation or something like that. You're going to allow your end user to upload an image and view that image so that they can say, oh yeah, that's me.
Now typically you might drop on the upload control, as we've got here, and you followed our other example and said, well, we're only going to support JPEGs, only going to support extensions of that, so we're not exposing ourselves to the malicious code attack. However, what I've got here is a file with a JPEG extension. I'm going to go upload, and it's now in our folder. If I jump back to my page, I now want to view that image. And here we've got a page, and I'll show you the markup just of the page for viewing it. And boom.
Ow. And you may have guessed from the name of the file that we're showing here some basic cross-site scripting attack. XSS cross-site scripting, by all means go and Google it. It's kind of interesting. It's a way of getting a file onto a server that gets executed either by the server or passed back to the browser and executed on the browser. And that code should not be executed at all. Here we have a bit of if you like, HTML. It's actually an SPX type thing. And boom, here we go. Alert, hello world, your site has been hacked. So imagine that there was not an image at all. It had the right extension, whoopee, but it wasn't an image. And images are, I'd say, a kind of special class of things. Because they're, I'm going to say something stupid, they're visible everywhere. And your users will be uploading images. I can pretty much guess that.
It's certainly a common thing where people are wanting to upload avatars and other things. So this is the actual code for the binary image viewer that we're looking at. The markup, straightforward, nothing there. If I jump to the code behind, we can see that the image was being read. Typically, this would be done from a database, but for our demonstration, we're just using a file that was saved out to avatar, and that's being read back into a byte array, and then we're displaying content type of image and then outputting that byte array. So this is not a best practice, and in fact, what we need to do is get rid of this line here and bring in and specify that the image type is of a JPEG type. And for additional validation, you can use this header, which is going to specify the no sniff on the X content type options. So if I run this example again and do my image viewer, I'm now, instead of executing that potentially dangerous code, I'm going to be seeing this message saying, hey, can't display this.
So again, this is an example of being more secure in how you respond to requests. Now, be aware that, you know, stuff you may get from your end user may have malicious code in it, and stuff you send back to the user may also have malicious code in it inadvertently to you. So be more secure. In other words, here we're saying, well, this is an image viewer kind of thing. Let's force the response headers to say, this is an image. It's a JPEG. And, you know, let the browser do its stuff, which is what just happened, basically. The browser said, that's not an image.
Absolutely. Interestingly, dare I mention, Microsoft Edge has that protection built in already, but whether that's going to disappear when they, what did you call it earlier? Chromify it.
Yes, yeah. I don't know whether everybody heard this, but Edge, Microsoft are deciding to use the basic Chrome code for the next Edge or something, so they're Chromifying it. Oh, there goes my phone.
Now, one thing that I want to look at inside the file upload control was how can we also stop that file from being uploaded in the first place? One of the things we can do, we've got our upload control as we had before, only this time I'm going to uncomment out a few lines of code and then explain what we're doing. So after the stream or after the file has been uploaded, we then attempt to read and create this stream and pass it into this new method called isValidImage. It's a simple enough check that simply retrieves or receives the stream, sets up a try catch, and says, okay, try and use that stream to create an image object. If that fails, then it's going to return a false. We don't care why it failed, there's a problem. Whether it be a corrupt file, a different file type that's not a one that is supporting of an image, or in our case, it's that malicious code. If it does represent an image, then return true. Save that.
So in other words, if you're expecting a file of a certain type, verify that it is of that type.
Invalid image. Now, of course, there's one other thing that simplifies all of this process.
Of course, we have a control for doing this. So
the ASPX binary image control, out of the box, has all the built-in support, no code required. It's going to validate that what you're actually uploading is what you're expecting. So at that point, it's not going to save my avatar picture out for that reason.
So because a lot of websites, a lot of web applications use binary images, allow users to upload them and view them and all that kind of stuff, we created a control to do just that and make sure that it is secure.
Final thing on uploading images, of course, set your maximum uploaded file size, because it's the simplest thing that's going to prevent denial of service attacks. Make that image size, maximum size, relatively small, and you won't suffer from those DOS attacks. Now we're going to jump over to our MVC project, and we're going to take a look at Crosssite CSRF.
Crosssite request forgeries. In other words, look, when you use a browser to access something on a web server, or rather the browser does, sends a request to the server reads the request, and then sends back whatever response it happens to be. So if you're requesting a web page, your request will be, give me this web page, and the server says, oh, I've got that web page, here's the HTML. And what this particular issue is all about is forging those requests to the server to do something nefarious, to get something they're not supposed to see, whatever it may be. Crosssite request forgeries generally involve some kind of phishing page. So phishing as in PH-ishing rather than F-ishing. So some kind of phishing, so you send emails out to everybody in a company with some kind of phishing link in it, and somebody manages to click on the link, and then suddenly you're in control. And this is all about trying to get those kind of forgeries thrown out. So what Paul is going to show here is a grid. So we've got one application here. It's a grid, and you should be logged in to edit that grid. So Paul is going to log in, and he's going to log in as the admin because everybody does. And here we have a grid, and it's editable now. We can edit it. We can, do some changes. Fine, everything's groovy. But what we're going to do now is we're going to forge a request to the server. And this is generally done through Ajax. What this particular grid does, which is our grid obviously, is every change you make results in an Ajax call to the server. The server does some processing with the database and sends back whatever changes to the screen, whatever changes to the rendering are necessary. So what we're going to do is we're going to forge a request to the same access, say Ajax access point. So here we have, it's just a link. We'll show you the code in a minute. Oh, we're going to view the page source right now. There we go. The link is, all it's going to do is, oh, there's a hidden form here, look. Okay, it's going to submit that hidden form. And the hidden form is going to say, well, it's going to call the edit form delete partial Ajax call, and it's going to pass an ID and a value of 2. So it's going to delete.
So effectively, as a phishing page, it's going to remove line 2 from my grid, and I've got no way of actually controlling that. So send post back. This is the page that's being rendered from that callback. However, we go back to our real page and do refresh, and line 2 indeed has been removed by a third-party page, something that obviously none of us want. And it's typical for those types of attacks to alter emails or steal emails, passwords. And in fact, there's a couple of great articles out there on why you shouldn't use auto form fill for that very reason. Having hidden forms, you accept the fact that you're quite happy to have your page filled, and a heap of information that you're not even aware of is then sent back to a third-party server, and you can't do anything about it. So let's take a look inside the correct project at what's actually happening here and what we can do to actually mitigate that. As we saw before, the actual phishing page itself is quite simple. It's just doing this post back, and it knows from a bit of playing around inside the Chrome tools what the ID is and how to look for the value. So some of this background information, people are going to spend time just playing around, trying to work out how they can access your particular page. What we are interested in is looking at what the solution or how we can implement that. And it's all to do with these tokens, as Julian was noting before. So
yes, in essence, what we're going to do here is to create a unique token that goes along with the user and his particular session, and that token can't be forged because it's going to be cryptographically signed, and every request the user makes has to include this token, and the server is going to validate the token to make sure that it is valid, and therefore the user is who the user says he is, and so on.
Correct. So there's a page on the Microsoft site that talks in great detail as to how the validation, how the tokens work. So we'll be including, or there is a link to that on the detail as well. I want to look at so I'm working with a very small screen size here, so I'm going to have to use my search to find the correct details. Now, what was interesting when we were preparing this presentation, Julian, while I find my page, is that the WebForms version of this is actually quite difficult to replicate. So, and if you're using ASP.NET Identity, then those particular tokens and validations are used as well by ASP.NET to protect your site. Okay, the file I am looking for
is
it's a controller, so using anti, and here we go. So in order to actually prevent that from happening, once you've injected the token into your client side, which, as Julian mentioned, is done by basically creating a unique value based on a machine key, something like that, then you can add the declaration or attribute to say validate anti-forgery token. Want to run that example up again? I should have all three products back, hopefully. Wait for IIS to spin up. Yes, there's my three products. And I actually want to go to my post back page here. So we can still edit. This time I'll do a sad face instead of a smiley face.
Hey, you should have done it the other way around.
And now we're going to try and send that post back. And I get this validation saying that, hey, sorry, you can't call this page without actually having the correct validation token as part of that request, therefore protecting the user from that cross-site request forgery or hack.
Yeah. So in essence, what we've done is, yes, somebody could work out, what AJAX call to make to do a certain thing. But what we're doing here is we're giving that call a token, if you like, that can only be viewed from or used from the user's own session.
Absolutely. Now, we want you to be aware that in complex AJAX-enabled controls, they don't actually automatically include the token field's value in their AJAX requests. So instead, just as a little snippet, I won't bother messing around with that, you can come through and actually incorporate your token inside the request. So all of this and all the code they're showing is very available for you, and I'll take you through that in just a minute. Now, there is also the ability of implementing the same on the dashboard product. But what we're going to do is jump over to our website and start stepping you through some of the links and how to look through some of this in more detail. And then we're going to talk for a few minutes about authorization, which in itself is of quite a large topic, covering 3 of our largest visual or BI style products. But using the anti-forgery token with the dashboard designer, we've got some great code examples here, again for both styles of web project. And unlike the unceremonious yellow screen of death that we saw before, the dashboard will display a nice little message or toast. Toast is the word I was looking for, Julian. Toast
yeah, pop up some toast saying, Nana, Nina, 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 you can't do that.
Yes. All right, let's scroll back up this document and take a look at authorization. We saw before that, go home, I'm logged in. If I want to log off, you're going to use authorization when accessing things, reports, dashboards, and even down to what you want your end user to have available for the query builder. But if you think in terms of you've got a public website and there's a report using the DevExpress extra reports engine that you want people to see, you can launch the report and we're going to see a nice report. Got my pages, got all my usual details, exporting everything that is available out of the box. However, I now want to look at a report that is only available to somebody who's logged in. So I'm going to be putting that behind a controller to say you must have authentication to view that. That in and of itself is okay unless you've then got roles. So think in terms of public being a role. We've got admin, which might see everything, and then we've got, say, the technical evangelists that only see limited things. So based on which user is going to log in as to what might be available. So John logs in, and John's got access to John's report and the public report. Make sense? John's got the ability to edit. We saw before when public logged in, there was no option as to what reports were available. And in fact, if I now log in as admin, we're going to see that I've got admin reports, John report, public report. And again, I've got the ability to edit. So in terms of setting that up, there's a number of different things we can do. Again, I'm not going to try and go through all of the different processes here code-wise because it just takes focus away from what we're trying to do. But in essence, for each of the products, there's a set of attributes or a set of inheritance classes that you can implement that will take you through that process. I would have preferred to see maybe a role instead of a username here, but it's the same practice, same principle. We can see that here we've got a method returning a list of available reports based on what the current user is. So we're getting the identity of the user and then building up this list of available reports. And we can see here the difference of, or why the user admin was able to see all of the reports versus the user John who could only see one report. And of course, if the public user, there'd be nothing returned in that. Understand that this is a simplified example. Some of this information you'd be having inside a database table or dynamically created. You wouldn't be necessarily expected to even know all of the report definitions at this level. But we're trying to give you the overview here as to how you can protect those reports and protect your end user information. Similar principle for being able to get through and edit. Now, I'm not going to step through and read all of this. You can do that in your own time. The examples do go through quite clearly and start to show you what the end user is going to happen. And the example here is if somebody tries to paste a URL or tries to take information for, or we can see here that the document viewer fired the method open report with admin report. If somebody tried to spoof that and they weren't validated, then they're going to start getting errors shown so that they can't actually hijack that information. Does that make sense, Julian?
Absolutely. In essence, I mean, that code that Paul was showing earlier on, I mean, you're hard coding your report names, hard coding your usernames. Yeah, you wouldn't have that in a real application, but nevertheless, there'll be some kind of table where you are linking names or roles to reports and so on and so forth. So this shows you, how to use authorization so that your end users can't view something they're not supposed to be able to view.
Absolutely. Just scrolling down to finish, exactly the same principle for the dashboard. We've got some examples here. Again, whether you're using MVC, whether you're using WebForms, how to implement specific controllers with access rules for each of those viewers. Now, Julian, talking of dashboarding and reporting, specifically, we are going to be doing some technical, I think 400 level webinars coming up over the next couple of months. Some real deep dives.
400 level? Wow.
Some real just get down and dirty coding sessions on how to use some functionality in there. So I'm just going to throw that little marketing line out there as we do.
I should have to do some revision then.
Why not? Now, I've not taken a look at any of the questions yet, so do we want to maybe have a look through some of them?
Yeah, why not? The only thing I'd point out to people at the moment is we do a lot of security investigations, whether they're prompted by our customers saying, whoa, what about this? Or whether we discover something online, for example, where people are talking about a certain vulnerability and how to get around that vulnerability. We do these security investigations pretty much all the time. The GitHub page that we were showing earlier on, that you can visit, and Paul will be giving you the full link in a moment, shows our current understanding of how to ensure secure applications using our controls at this point in time. And we do regularly update our suites, our subscriptions, to mitigate vulnerabilities as and when required. Obviously, we'll be updating that GitHub page when required, but I really would ask you to make sure you get emails from us when we basically send out an email saying, oh, there's this security issue, it has been resolved in version, say, 18.2.7, please download this now if you're using such and such a control. We send those out fairly regularly when we discover vulnerabilities or when we mitigate them. So please be aware of that and make sure that you're always using the latest version of a particular release. Oh, there it is. Go to github.com, DevExpress and the ASP.NET Security Best Practices repo.
Okay, questions. The team have been busy as always answering, but what I might do is read through some questions and some answers.
Oh, okay. You're more organized than I am then.
That's
The
okay.
questions panel.
So one of the questions is, how can I define restricted extensions, which we covered. Basically, you can do it in your code behind an event, or you can set the allowed file extensions inside the validation settings tag on the file upload control. Other things we have. So a couple of people asking about the link, which is now posted and still up on screen. The other thing
I want to emphasize is when we write a control, we try and make it as wide-ranging as possible. When you're talking about security, you don't want things to be as wide-ranging as possible. You want to nail it down. You want to impose limits. So all I would say is be aware that if you're using a particular control that might have security implications, it probably already has methods and properties which allow you to limit what the control can do. So, we were talking earlier on about, setting file extensions and all that kind of stuff. So be aware of that kind of thing and make sure you just don't use a control straight out of the box. You look at how you can limit the implications of using that control for your particular web application.
One question for file extensions: what would we want to control in a file uploader or file manager? Is there a blacklist property or only working with whitelist? So by default, the upload control and the file manager allow uploading of any file. There's no blacklist property, but you can use that allowed file extensions to define what's happening. And of course, in the file manager control, you have the access rules set around that as well. The one question came through, what about .svg files, which Julian loves, but of course they can contain nasty scripts as well. So is there any way to check that? And the answer is, by default, the binary image control does not allow uploading of SVG files. It only works with binary image data, sort of hence from the name.
In fact, that's an interesting question. I wonder if there's somebody out there who's actually written a validator for SVG to say, yeah, this is a valid SVG, or what the heck is this? This is not SVG. Because after all, SVG is a script.
You're free this weekend.
Yeah, right. Okay, fine.
Yeah, there was one thing that I was going to just show people when we saw that error message a little earlier was, of course, what happens. I love 404 pages. What's your blog post, Julian?
What's my blog post? What? It's boyette.com.
boyette.com/meh. So when you talk about 404 pages, instead of yellow screen of deaths, you can end up with, of all things, a Peugeot 404. In fact, I think that's Julian in the front driving.
Yeah. Brilliant 60s car, I tell you. They were wonderful. Anyway.
But you should never see a yellow screen of death.
You're talking about my blog there. You were talking about. It's just weird. I actually log every 404 access to see what people were trying to access. And somebody last week tried to retrieve via URL all of the Git folders that get generated if you're using Git as your repo.
On your production machine.
On my production machine, on my production blog there. Yeah. I mean, yeah, the folders are not uploaded and all the rest of it. Somebody actually tried to access those URLs. So just, be warned, people do, or script kiddies do weird and wonderful things and try and access things they're not supposed to. So make sure your web application is locked down.
Back to the questions. File Manager, useful component for ASP.NET. Is there a similar component for SPA applications such as DevExpress? And the answer to that is not yet, but it's on our future plans. Big smiley face.
Well, the thing about DevExtreme is it's client side. So, you know, the attacks via Ajax, for example, when we're talking about cross-site request forgeries, that still happen. But again, it's on the server. The server does the work. The forgery tokens are not available on DevExtreme at the moment, I must admit. But, you know, there's still a server aspect to DevExtreme, even though it's pure client side.
Absolutely. Another question, do you need to place your anti-forgery token on every form, or is it possible to just set it once? And unfortunately, you need to put it on any form where data is submitted back to the server.
So now, yeah, form submit or Ajax call, have a forgery token.
Now there's a couple still that I need to check with the team on. So Julian, as usual, I'm dubbing you in for the blog post with the follow-up questions.
Which I'll pass back to you, because I am going to Ignite London, or London Ignite, which is next week.
Is it going to be as good as Sydney was last week?
I don't know. We'll have to see. So if you're in London, come along to Ignite. It's in the Docklands, I think.
And of course, we have some other amazing webinars coming up over the next few weeks. So maybe we can hand back to Amanda.
Hello, gentlemen.
Amanda.
All right, everybody. Like I mentioned before, today's webinar will be made available later on our DevExpress YouTube channel. I'm going to post that link right now in the chat box. There it goes. While you're on our YouTube channel, please subscribe and also ring that little notification bell so that you are notified whenever we release new content. You will also get a follow-up email with a link to this webinar recording. And like Paul mentioned, we do have a couple webinars coming up, revamp your WinForms apps, MVC tips and tricks, and more. You can register at devexpress.com/webinars. And that is it for this one. Thank you so much to Julian and Paul. Thank you all for joining us. And of course, thank you for choosing DevExpress. Bye-bye.